What's up, y'all? Today we're going to be building my attribute component system. What I see a lot of new developers do when they're dealing with stats or attributes is to make a bunch of variables and just throw them all over their game on all kinds of different actors. So this causes a lot of organizational flaws, but also it makes the overall architecture of our systems a lot harder to manage. So we're going to be fixing that today with one component and an improved mindset on creating new systems in Unreal Engine 5. So the problem is when we create a bunch of variables for health, armor, attack damage, attack speed, and so on and so forth, and we just throw them into the player and then throw them into the enemy AI and maybe into some other actors like turrets or something around the map, what ends up happening is it clutters a lot of our blueprints because the variables are just everywhere. And there's also an overall lack of scalability when getting variables from different actors. So the attribute framework that we're building today gives us three primary benefits. First off, it decouples a lot of our systems. Other actors or systems in the game don't need to know the exact class that we are trying to get attributes from. They just need to know that the actor has an attribute component. This improves our reusability a ton. Any actor can have any attributes simply by adding the component and setting a default value. We can even add attributes during runtime. If, let's say, an enemy gets hit with some poison damage, we can add a poison attribute to them. And the last main benefit is scalability. All of our systems will continue to work regardless of how many actors end up using this component. So to build this, we are going to be relying heavily on gameplay tags. So what are gameplay tags? Well, gameplay tags are essentially a way to describe things in our game using labels rather than just hard-coded checks. So gameplay tags can be used in a lot of different contexts. Some of the more popular ways to use them are player states and AI states, damage types. You could use them as IDs for different weapons or items, or in our case, we'll be using them to describe actor attributes. Using gameplay tags allows us to do some simple checks to quickly see if an actor has a gameplay tag on it. So in this case here, the player can have a weapon. It can be melee or ranged. Then we have a few different types of weapons for each of those categories. We can simply ask the player, does this actor have a ranged weapon? And the check will work regardless of what type of ranged weapon they have. They are essentially like putting your data into folders. You can have folders inside of folders inside of folders. One of the biggest benefits of using these tags is we don't actually have to update any code. So if we look here in this example, we have an enumerator with damage types. So in this case, fire, ice, and poison. And in this code, we can simply check if the player has been hit by some damage type. We can use a switch to check the type and apply an effect onto the player. So here's the problem. If we were to add a new type, let's say electric damage, we would then have to check all of our code because some switch statements or other logic might have broken. In many cases, we can add new tags without modifying existing code, however, which makes our systems easier to extend. So you might ask, why not just use variables? Well, let me ask you this. What happens when I have a game that uses some kind of health and damage system, but now I want to add armor to it? Well, I then need to go into each of my actor classes, make the new variable, and tie it in with whatever systems actually use it. If we instead have an attribute component, we simply add a new attribute definition and assign it to whichever actors need it. If you combine that with a modular damage system that isn't specifically looking for different classes and is instead able to deal damage regardless of the actor, as long as they have an attribute component, the amount of work you need to do decreases dramatically. So why use a component? Well, putting this logic inside of a component class allows us to give attributes to any actor in our game. Some developers like to make some kind of base character class that all other characters in the game inherit from. They usually put some kind of basic logic for like health or movement in there, and all their enemies and their player and any other kind of character in the game will inherit from that base class. But here's the problem with that. What if we need those attributes in other types of actors, not just characters? For example, here, we have an explosive barrel actor that might need health and damage. We don't want that to inherit from the same base class. So we make a component that can be put onto any actor and we only include the attributes we want on said actor. All right, y'all, let's get building this system. So I'm here in an empty Unreal Engine project. I am using Unreal Engine 5.7.4 if you wanted to follow along on the exact version. However, the system should work for every Unreal version that has gameplay tags in it. First thing we're going to do, we are going to create our folders for blueprints, and we will just add this to a component folder as well. I like to stay super organized. So we're going to make a new blueprint class. This is an actor component, right? Not a scene component, an actor component. The difference is that a scene component actually has a transform. It exists somewhere in the world. Actor components don't. So new actor component, BP, attribute component is what we will call it. Let's pop that open. So the system's actually really simple. We only need, I think, 6 different functions and 1 variable, 1 event dispatcher. So let's start with our variable. We need a map of attributes. So we will call this attribute, attributes, and it's going to be of type gameplay tag. Now it will be a map though, which is essentially an array of key and value pairings. So the value type will be a float. And we don't need to set anything in here. These attributes will be set either during runtime or just on each individual actor. So let's start with our get all attributes function. Get all attributes. So all this is going to do is return our attributes variable we just created. Just like that. Nice and simple. Next up, we will create a function called has attribute. So here we're going to check if we have a specific gameplay tag as a specific attribute on the actor. So we are asking for an attribute tag here, which is going to be of type gameplay tag. And all we're going to do is we are going to look for contains inside of our map of attributes the tag that we are inputting. And then we are just going to return whether or not we contain it. So we look inside the attributes map for this tag, and if it exists, we return true or false. So next up is get attribute. This is kind of the bread and butter behind the system. You'll be using this probably all the time. All we're doing here is getting the specific value for the attribute that we input. So similar to what we had on has attribute, we need to input a gameplay tag. We'll call this attribute tag like before. And so we need to find in our attributes, find this tag that will return whether we have it and the value that exists with the tag. We want to branch off of this. So we are going to make a return node, and we are going to plug in our value. And if false, meaning the tag does not exist, we did not find it, we will return 0. Let's add attribute value as our return name. Now you can change this slightly to include whether or not we were successful, like so. And that would essentially make has attribute redundant. You don't really need to do both, like to have has attribute and to return a return value here. It's not necessary, but maybe you'd like this more and just remove has attribute. I personally like having them separate, so we're not going to be doing that in today's video, but the option is there if you want to do that. So the next function we're going to create is remove attribute. If there is ever a time you need to remove any specific attribute on an actor, maybe it's like a stunned state or something like that, some kind of damaged state, like if they have poison damage. So again, we are going to ask for an attribute tag. Common theme here. We are going to get our attributes, and we are just simply going to remove this tag. And we just want to return whether or not we were successful there. in case there's ever a time that you need to know. Okay, next up is set attribute. Set attribute. We are going to again ask for a tag, so the attribute tag that we are trying to set, and then we need a value. So new value is what we'll call it, and that will be a float. That's the wrong thing. We are going to get our attribute here and add. Line all these up, stay nice and organized. So all this is doing is it checks to see if this attribute tag we're inputting exists inside of our attributes map. If it does not, we're going to simply add it to the map. That's how you would add a new state, for example. Maybe you stun an actor, and so you add a stunned gameplay tag to them. But if it does already exist, we simply override the existing value with the new value we've passed in. So the last thing we want to do in this function actually is add an event dispatcher. So this is a super useful part of our component here. So on attribute changed is what we'll call it. This needs 3 different inputs. Okay, so we can add a new input up in the top right over here. So we need an attribute tag. Let's call that gameplay tag. And then we need 2 floats. Float. So old value will be the first float and new value will be the second. So we are going to call on attribute changed. The tag is going to be our attribute tag, which we've passed in over here. And we also just want to simply get attribute. Oh, we've actually made a mistake. Our get attribute, some of these need to be pure functions, which we skipped. So get all attributes, pure. Has attribute will be pure. Get attribute will be pure. Okay, so now that that's pure, we don't have to tie it into the execution line. And we can now just get our attribute here and pass that into our new value. Now, old value we don't actually have yet, so we want to come to the start over here, and we can do this exact, didn't copy, we can do this exact little function here, get our current value before we add anything, and we can save this as a local variable. So old value is what we can call it. In there. So we have our old value saved. Then we update the value. Remember, if we don't find anything in get attribute, we simply return 0, which is what we want here. And then when we call attribute changed, we just pass in our old value. So why is this event dispatcher useful? Well, mainly for UI. Instead of setting our attributes in, let's say, tick or binding them in our UI, we can simply bind to this event and update all of our variables super quick without having to use tick, which is super useful. All right, let's get our last function in here. Last one will be add to attribute. So we are going to once again pass in an attribute tag, and we will also pass in a delta. That is the amount that we're changing by. Attribute tag, and this will be of type gameplay tag, like so. So what we're going to do is we are going to first get our attributes. We're going to find our tag that we're passing in here. And if it exists, come on now, we will be setting this as a local variable for our old value. Old value. Let's make sure we are nice and clean with our wires here. If it's false, we simply need to set attribute. And we will pass in our attribute tag. and our delta, which is down here. Plug those in. Now, if we were successful, we already have this attribute in our map. We are going to want to add to it. So we can get our attributes. We can add. Now we're going to take our old value and add to it. We're going to add our delta. Just duplicate this, maybe. It won't let me. There we go. We add our delta and just pass that straight into here. Let's get everything cleaned up. And the tag we want is just our gameplay tag. Not our gameplay tag, our attribute tag, sorry. And the last thing we do is call on attribute change, just like before, with our tag. It will not let me duplicate nodes right now. Do not know why. We pass in our tag, we get our new value with get attribute, passing that in as our new value. Make things nice and tidy. And our old value is just the old value we saved earlier. So that's actually it. That's everything we need for our attribute component. And now let's actually add some gameplay tags we can use. So the way we do that is we go up to Edit, Project Settings, and we can look for this gameplay tags category here under Project. Click on that, and we can see Manage Gameplay Tags. So there's a lot of ways you can organize this. I'm going to be showing you how I personally like doing it, but you're free to come up with your own system here. This is really, use it however you need to use it. So we can add a new gameplay tag, and we need to make sure we select a source. So our source is going to be default gameplay tags.ini. And for me, I like having a parent all the way at the top just called attribute. So we're going to start there with attribute. Underneath it, we can either, if it's a simple game, just straight up add our attributes under it. Or if it's a more complicated game, we could do something like having defense and offense, utility stats, like what I showed earlier in the video for the examples. For this example, it's going to be super simple, so we're just going to add straight to our attribute. So we can click on the plus. It already gives us our attribute here. And we can write, let's go with health to start with. And then just to show you can add a new attribute in a different way, we will type attribute, period, and we'll do damage. So we'll add those two attributes. Now these are damage and health are just types of attributes. So for our example, we are going to create a new actor. I'm just going to put it here. We're not going to put it here. That would bug me. We're going to put it here. That's fine. And this is just going to be BP explosive barrel is what we'll call it. So the way we use our attribute component is super simple. We just add the component. That's it. That's all we do. Add the component to our actor. After that, we can simply go over onto the right where we have our attributes, and we can add new attributes. We can select health and set the value. We'll say 100. And you can add more for damage. Let's do 1,000. Big number. So it's literally that simple. That's all we need to do. Let's just quickly add a cylinder mesh to this example. Compile and save it. We'll go into our test level here. And we will drag one of these out. And we will go to our open level blueprint. We will create a reference to this explosive barrel. And we will get attribute component. Not sure why we're getting owner there, but we have our attribute component here. Now we can call all these functions. We can get attribute, and let's just say we want to get our health, which if you remember was 100, and we can just quickly print that here. And if we were to play, we'll just see 100 being printed. And it's really just that simple. Now we have all these functions we could use. We could get attribute, we can has attribute, we can add to attribute, and all of our systems can use this component. So I'm going to quickly show you one other optional upgrade we can make to the system depending on whether or not you need it. So to begin with, we're going to go to begin play, and we are going to get all actors of class. And we are just going to get all actors in the scene, right? And we will do a for each loop for each of these. So what if we wanted to print every actor's health in the scene? We couldn't simply get attribute component. It doesn't exist, right? Because the actor class doesn't have it. Our explosive barrel has it. We could get component by class, and this totally works. We can plug in our attribute component. Attribute. I've conveniently spelt that wrong. We probably want to spell that correctly. We can check is valid. And if it's valid, we can get attribute, we'll say our damage. Let's get rid of this so we don't have it. And we will print that. So now we should see our damage, which should be 1,000, printed once on begin play because our explosive barrel has an attribute component. Now, this works fine. Like you can do this. You can get component by class, and that's not necessarily a problem. But what get component by class is doing is it's looping through all of the components that exist on every single actor that we call it on, right? So in some cases, you might have a lot of components, and that wouldn't be very performant. In a lot of cases, it's fine, but sometimes you might not want that. So what we can do alternatively is we can create a blueprint interface. So we will quickly do that. BPI attribute. And all we're going to do is make one function called, let's say, return attribute component, which will output our component, which is spelled incorrectly. And now what we can do is go to every single actor that has the attribute component, and we can give it this interface. So BPI attribute, and we can simply define this function by passing in our attribute component. File and save that. And so now if we go back to this example, we don't need this. Instead, we can just return attribute component as a message. And we should probably do an is valid just to be safe. And if it is, we can pass that in. So just slightly more performant if you have a lot of components on actors that have the attribute component. So that's the entire system. Tie this in with any other systems that you may need or use. If you have other generic components like a health component, these two things can work together really well and make everything super scalable. Any actors can use attributes, or if you have the health component, a health component. And it makes it a lot easier to make new features a lot quicker. So before we wrap up, if there's one thing I want you to take away from this video today, it's that we want to build systems around capabilities rather than specific classes. Notice that nowhere in this system did we care whether we were dealing with a player, an enemy, a boss, or even an explosive barrel. The only thing we cared about was whether or not that actor had attributes on it. By designing our systems this way, our code becomes more reusable, easier to maintain, and much easier to extend as our project grows. Instead of constantly writing special case logic for new actor types, we can build generic systems that work everywhere. That's really the biggest benefit of the attribute framework we've built today.